Okay, let's go ahead and work some problems like you'll see on the next exam. Find the remaining zeros of a polynomial given some of them. Okay, let's take example 1. Suppose that 1 minus 2i is a zero of the polynomial f of x equals x to the fourth minus 2x cubed plus 9x squared minus 8x plus 20. Find the remaining zeros. Okay, now I promise that I won't lie. If I claim this is a zero of the polynomial, it actually will be. Okay, how many zeros will there be total? Well, from the fundamental theorem of algebra, if we are allowed to go to the complex numbers and include multiplicity, there should be how many? Exactly 4 of them, the same as the degree here. So far, we only know 1 of them, so we've got to find the remaining 3. Now, one thing you will notice about this polynomial f of x is that it's a real polynomial, right? It's even more than that. It's an integer polynomial. But the main thing is that it's what? A real polynomial. And this is an imaginary zero. Now, you remember from the conjugate zeros theorem that what? Imaginary zeros of real polynomials come in conjugate pairs, yes. So the first thing we can do is just take the conjugate of 1 minus 2i to get 1 plus 2i. That has to also be a zero. Is a zero of f of x. Okay. Alrighty. So now we actually know how many zeros. We know 2 zeros now. So that means because the degree is 4, we've got 2 other zeros to find. Now remember that every polynomial will factor in terms of what? Its zeros. Okay, so this would be what? X minus the entire quantity, 1 minus 2y, should be a factor, right? And x minus the next zero, 1 plus 2y, notice my parentheses around that, should also be a factor. And my leading coefficient is actually 1. You remember from the fundamental theorem, that would be out front here. Well, that's just a 1, so I'm not going to bother actually writing it. But the point is, these two factors will both divide, in fact their product as well, will divide the polynomial f of x. So there's going to be a quotient right here, q of x. Now q of x is going to be of degree 2 because you can see when I multiply these two factors, I get a polynomial of degree 2, and f of x is a polynomial of degree 4. Okay, now let's actually go ahead and do this. We're going to find what q of x is by first of all multiplying these two together. Now I hope you can remember how to do that. That would be what? X squared minus 2x. 1 squared and 2 squared is 5. So my polynomial f of x should be x squared minus 2x plus 5 times some polynomial q of x. No remainder at the end, all right? So what should happen? Let's see if we've got room to squeeze this in here. I'm going to take my f of x and perform a long division. So that goes in the doghouse here. Okay, so I'm looking to find that quotient polynomial q of x, and I'm dividing this by x squared minus 2x plus 5. Okay, and remember how to perform a long division here? I'm not going to use synthetic division on this. I could have twice, but that would involve using complex numbers. It would be a mess. Let's do it this way instead. Now what's x to the fourth divided by x squared, right? That's x squared. Multiply by x squared on the divisor. That's x to the fourth minus 2x cubed plus 5x squared. And then remember, we always what? Subtract. I'll remind us that we're doing that because of that there. Okay, cancellation. Hey, cancellation again. And we would have what? 4x squared minus 8x plus 20. Okay, now let's go ahead and divide this by this. That would be what? Consider 4x squared divided by x squared. That would be 4. That's a constant term, so I'll write it right over the constant term here. Okay, multiply, I would get what? 4x squared minus 8x plus 20. And the difference there is 0. Yes, no remainder. This up here is what? Our q of x, right? That's our quotient. So what we really found is that our polynomial f of x looks like this. f of x is x squared minus 2x plus 5 times x squared plus 4. Okay? So that's our q of x here. Now if I'm setting this equal to 0, okay, and I'm looking for zeros, the solutions to this, right? Well, I don't want to look here for any more solutions. That's where I get the 1 plus or minus 2i, right? I've already done that. The remaining zeros will be found by taking that factor, setting it to 0 and solve. Okay? You guys see x squared would equal negative 4. When I set that equal to 0, that has two solutions, plus or minus 2i. So the zeros of f of x are what? 1 plus or minus 2i and plus or minus 2i for a total of how many zeros? 4, right? That should be all of them then. Okay, the same as the degree of the polynomial. Alrighty, so consider a problem like that possibly on the exam. Okay, let's take another question here. I claim this will be a given here. 1 is a 0 of this 4th degree polynomial. See if you can find the remaining zeros. Once again, there's going to be a total of how many? 4 zeros. I've got to find the remaining 3. Now this time the 0 is a real number, right? So I can't just what? I can't use my conjugate, trick or anything like that, because that's not an imaginary 0. That's a real number. But we should know that what? Our polynomial p of x should be divisible by x minus 1, right? Sometimes some quotient q of x, okay? X minus 1 should divide p of x, get a quotient, no remainder, right? Okay? By the way, this is a monic polynomial. This is actually going to be a 1 out here again also. Q will be a monic polynomial also. Now, remember, if I've got to find q of x, I need to do what? I need to go p of x divided by x minus 1. What kind of division do you want to do? Do you want to do a long division? That would work. Long division always works. But I think it would be better to go ahead and use synthetic division, right? Remember, you're dividing by x minus 8. That would correspond to x minus 1. That would imply the a is actually 1. That's the number that goes out here. Okay? Now let's make sure that's in descending order, right? The dividend polynomial that I'm dividing into. And make sure you're including any missing terms. Doesn't look like we have any missing terms in this particular case here. Let's go ahead and do this and see what happens. Okay, let's perform our long division. Remember how it works? Just bring the first one down and then multiply these two and you get 1. Now remember, you're adding, not subtracting like long division. Add those two. You get 3. 3 times 1 is 3. Add these two, you get what? Negative 2. Multiply by 1, you get negative 2. Add these together, you get negative 6. And then go ahead and multiply these two, negative 6. And then add these and you should get 0. But I think I messed up here somehow. Okay? That's supposed to be a plus. Okay? This is called a cheat at the end. Okay? Now add those two and what do you get? You get 0. Okay? So you get 0. And then, what's our q of x? Well, remember that that's the remainder. That would be the polynomial evaluated at what? At 1. Okay, that better be 0. Here are the coefficients of the quotient polynomial. Okay, let's go ahead and write what that quotient polynomial would be. And that would be what? X cubed plus 3x squared minus 2x minus 6. And then to find the remaining zeros of p, I would go ahead and set that equal to 0, right? Now, do you know any techniques that you could use on this? Okay, I'm thinking of a technique that you might have used from in a previous class, which is factoring by grouping. Okay, and in this group, I think I can factor out the negative 2 like this. Do you see? So I had this as a grouping and this is a grouping. Don't forget when you're factoring out that negative 2 sign here, that is factored out of both those terms. So just as a quick double check, x cubed plus 3x squared minus 2x minus 6. Looks good. You see a common factor between the two? So we've got q of x actually factoring this way, and then I'm setting that to 0 and solving. So it looks like I'm going to take each of these factors, set them to 0 and solve. Let's maybe take x plus 3 and set it to 0 first. That would imply that x is what? Negative 3. That's really easy. Okay. Alrighty. And then I've got this what? This other factor, I'm going to set that to 0 and solve. So let's go ahead and do that. Let's go x squared minus 2 is equal to 0. Go ahead and add 2 on each side. Okay. Take square roots, write absolute values, and then get rid of them. You can see that's plus minus the square root of 2. So what are the zeros of my polynomial? The zeros are, let's write them as a list here. I think we started out, we had what first? 1. And then the next one I found was negative 3. Okay. And then what? Plus or minus the square root of 2 for a total of how many zeros? 4 zeros. Okay. You ready? Now, here's one where it's a third degree polynomial. You could try setting this to 0 and factoring by grouping. It would not be very easy. The factoring by grouping directly would not work. What are we going to do in a case like this? Well, you remember, if I set this equal to 0 here, that because this is an integer polynomial, I can use the rational zeros theorem. Maybe that'll help. Let's try it. Okay, so use the rational zeros theorem and see if this will help. Okay, do you remember how it goes? In this case, it wouldn't matter what order I do these in, because what? The leading coefficient and the constant term are exactly the same, but I'm going to go factors of what should it be first on top? Factors of 2, the constant term here. Okay, what are the factors of 2? Remember, these are integer factors, so it's plus or minus here. Plus or minus 1, plus or minus 2. And then the factors of what underneath? Factors of the leading coefficient, which I stated already is also 2. So that's coming from there. This would be the same factors. Okay? So here's the possible rational zeros. Okay? So we're saying if there's any rational zeros, they'll be in this list. Okay? It may be that none of these are rational zeros, and we'd have to resort to something like the cubic formula, which is something maybe you've never heard of, but there is a cubic formula just like there is a quadratic formula for this, but that has sort of fallen out of the curriculum in recent decades. Anyways, what would be the possible rational zeros? Okay, plus or minus 1 divided by plus or minus 1 would be plus or minus 1. Plus or minus 1 divided by plus or minus 2 would be plus or minus a half. Plus or minus 2 divided by plus or minus 1, plus or minus 2. And then plus or minus 2 divided by plus or minus 2 is really just plus or minus 1. And I've already have that in my list, right? So these are the possible rational zeros, or potential rational zeros. Okay? Now, I'm going to sort of cheat here. What would you actually do here? You could go through one by one and test these, right? You could go through one by one and test these. I'm going to go ahead and test one. Okay? Now, I'm going to do what? I'm going to use a synthetic evaluation, right? It's like dividing the original polynomial h of x by x minus a half. Okay? This would be what? Testing if a half, for example, is a zero of the polynomial. So I'll go 2, 5, 6, and 2. Okay? And remember how to do this? Bring it on down. Okay? Multiply, you get what? 1. Add, you get 6. Multiply, you get 3. Add, and you get 9. Okay? Multiply, and you get 9 halves. Add, and you don't get 0 here. Doesn't really matter what I got here. It isn't a 0, right? Okay? So what have we shown? 1 half is not a 0. Okay? I could plug 1 in my head here and see that that's not going to work. Okay? I don't think negative 1 is going to work either. Let's try minus a half. Do you see what I'm doing? Just going through there hoping that one of these will be a 0. Let's try minus a half instead. Okay? All right, we've got what, 2, 5, 6, and 2. Let's do it again. Bring the 2 down, multiply, we get what? -1, right? Add, we get 4. Multiply, we get what? -2. Okay, is that right? Yeah, -2. Add, we get 4. Multiply, we get -2. Add, we get 0. Okay, so that's my polynomial h evaluated at -1/2. That's a 0. Cool. So what we found is what? -1/2 is a 0. Okay. Now, this would be the quotient polynomial here. That would be what? Second degree polynomial. So it would be this. Okay. Now, how are you going to solve that? Well, the first thing I would do probably is divide a 2 out of everything. Divide by 2 on both sides and you end up with this. Okay. And then what? Go ahead and use the quadratic formula on this. So we'll go x is -b plus or minus the square root of b squared minus 4ac all over 2 times a. So that's 2 times 1. Okay. So that would be -2 plus or minus 4 minus 8. So that would be what? -4, wouldn't it? Okay, 4 minus 8. Yeah. Okay. And there we go. We're dividing that by 2. Now this is actually what? -2 plus or minus, what's that? What's the square root of 4? 2, right? But don't forget you got a negative under there, so you've got 2i. Now don't forget, don't start slashing these 2 out in one place but not another. The 2 is dividing both terms. So x is -1 plus or minus, and then you get cancellation here, I. Okay, so here are the zeros for this polynomial. They are what? -1/2 and -1 plus or minus I. Notice that our polynomial was a real polynomial, so we better have what? The imaginary zeros coming in conjugate pairs, and we do indeed, and there we go. Okay, so be prepared for some questions along those lines on the exam. All right.